By now, you should be very familiar with the properties of parallelograms, and you'd be prepared to write proofs using those properties. So let's see how well you can do. This first figure of a quadrilateral shows three angles. So that's information that's been given to you. Angle BAD is 60 degrees. Notice how the letters are written, how that corresponds to the angle that's described. Angle ABC is 120 degrees, and angle ADC is 120 degrees. You are asked to prove that the quadrilateral ABCD is a parallelogram. You're going to write a two-column proof. On the left, you will have statements. On the right, you will have reasons. It's easier to see your proof if you write each given on its own line, so you can clearly see what information that we're using. 60 degrees, 120 degrees, 120 degrees, given, given, given. Then you continue. Angle BAD and angle ABC are supplementary. We know that because 60 degrees plus 120 degrees is 180, and that's the definition of supplementary. Your last statement is that ABCD is a parallelogram because you have been able to use a property of a parallelogram, the definition of supplementary. Let's go on. Another example. Given that angle CAD is congruent to angle BCA, and that angle CAB is congruent to angle ACD, prove that the quadrilateral ABCD is a parallelogram. Now what we're going to do is explore the fact that it looks familiar when there's a diagonal going through. We also called it a transversal when we were dealing with parallel lines. So let's mark this out. If we mark that as being a line and a line, which it is, but this time being parallel, then we should be able to see or recognize these angles as being alternate interior angles, just as this angle is an alternate interior angle to this. You can also say that these sides are parallel and the alternate interior angle still applies. Okay? So because of alternate interior angles, that makes the sides parallel, and when opposite sides are parallel, the quadrilateral is considered a parallelogram. And you may use the alternate interior angles are congruent as a reason for stating that the two sides are parallel, and therefore ABCD is a parallelogram because of a property of a parallelogram. Does that make sense? I hope so. Here's another example. Given that triangle MJK is congruent to triangle KLM, prove that the quadrilateral MJKL is a parallelogram. Okay, do you see those two triangles? Does that look familiar to you? What reason would you use for congruence? If you already know that the two triangles are congruent, that means that all 6 parts are congruent. How would you write that out? So I've given you the first statement, And I want you to take some time to write in your notes what other statements that you're going to make from what you've already known about proving that triangles are congruent. You have all 6 parts are congruent. Which 3 would you use? Any one of those reasons? So if you use the reason for alternate interior angles, that means that the sides are parallel. It also means that the sides are congruent. Therefore, the quadrilateral is a parallelogram. Look at your work. Make sure that you've written words that make complete statements, and that your last statement is that it is a parallelogram. Okay. Another example. Given that E is the midpoint of AC and BD, prove that the quadrilateral ABCD is a parallelogram. Now let's remember that AC is considered a diagonal. BD is a diagonal. What does midpoint mean to you? Well, midpoint is the definition of making a line marked into 2 equal distances, or bisect. Diagonals bisect each other by definition of midpoint. Diagonals that bisect each other is one of the properties of a parallelogram. Therefore, you can state ABCD is a parallelogram because of the property of a parallelogram. I'll give you some time to get that written. I always have to finish your proof with the statement that you were given at the beginning of what it is that you're supposed to prove. Okay, let's go on. When information has been given that angle ABC is congruent to ADC, angle BAD is congruent to angle BCD, prove quadrilateral ABCD is a parallelogram. Okay, by now you should be ready to set up your own 2-column proof. Statement on the left, reason on the right. I suggest that you give 1 line for each of the given statements. I'll write that out, just copy what you see for the 2 sets of congruent angles. And now that you have congruent opposite angles are congruent, you can state that the quadrilateral is a parallelogram, and your reason is that the property of the parallelogram when opposite angles are congruent. Good job. You should be ready to take your quiz for Standard 2.